Okay, for our warm-up today, we're just going to simplify some radicals. First question's got a square root. Second question's got a cube root. And the third question's got a fourth root. And what are the specific rules when we simplify to get things going? So we're just going to simplify this as far as we can. So this first question, if you see a number on the outside, you're going to want to make sure you remember what that number is, because we're going to use it later. Then we need to break down our numbers first. So 112, we're going to use prime factorization. That's going to be 2 and 56, 2 and 28, 2 and 14, and then 2 and 7. That's as far as you can go with that. If we look at our index, there's no number there, so the assumption is that that number is 2. So we have to circle 2 of a kind, so that we can bring it out. Anything that's left over is going to stay underneath the square root, so I put a square around it. So the next one, with our x's, you're going to take the exponent and you're going to divide it by the index. So 3 over 2 is going to leave you with 1, remainder of 1. So the 1 is going to come outside, meaning I'm going to have an x to the first power on the outside, and then on the inside I'm just going to have an x by itself. And then we do the same thing for the y's. You take the exponent 5, divide it by 2, and that's going to leave you with 2, remainder of 1. So the y squared will come out, and the remainder of 1 will stay on the inside. Once we do that, any circles or underlines that we have are going to be pulled out and multiplied together. Any variables are going to be pulled out, or if any variables that are left over stay underneath the radical. So here I've got 2 times 2 times 2. Then we look at our variables. We had 1x that came out, and then we had 2 y's that came out. So I'm just going to write y squared, because I'm dealing with the exponents here. And then I have my square root times whatever is left over inside this radical. So anything that has a square around it. So 7, an x, and a y. So from there we need to condense all this multiplication, which isn't too terrible. We got 2 times 2 times 2 is 8. We have an even index with an odd exponent. That means I'm going to have an absolute value for just the x. And then the y squared can stay as y squared times the square root of 7xy. This would be the final answer, simplified to radical. With a cubed root, you can have a negative on the inside, it's fine. If it's a square root or a fourth root and it's negative, you're going to have an imaginary number like what we have for this question here. So with this one, I know I have a negative. I'm going to underline that negative. I'm going to break down 16 and 2 and 8, 2 and 4, 2 and 2. I need to have 3 of a kind. 1, 2, 3. I've got 1 of them left over. I'm going to do the same thing I did with my exponents over here. So I've got 10 over 3 is going to be 3 with a remainder of 1. And then 20 over 3 is going to be 6 with a remainder of 2. So I've got 20 over 3, which will be 6 with a remainder of 2. So 6 times 3 is 18, 19, 20, remainder 2. That's how many are going to be left over. So cubed is going to be brought out. A single x will be left over. A 6th power will be brought out with a 2 or a square left over. Now I want to go ahead and just bring everything together. I've got the negative here, gets brought out. I have 1 set of 2's, so that's going to go right there. I have x to the 3rd power, y to the 6th power. And that takes care of all my circles. 2, the negative, the 2, the 3, and the 6, the 3rd power and the 6th power. Then I have to rewrite my cubed root. And then anything else that's left over. I have a 2 that's left over. I've got an x that's left over, and I've got a y squared that's left over. From there, we need to multiply things together if possible. No need. It's an odd index with an even Exponent, it doesn't make a difference. You don't need any absolute values for this kind of question. This is simplified as far as it can go. And then we have our last question. Right here, I've got a negative. So I know that if I have a fourth root or a square root or an even index with a negative on the inside, you're going to have I as part of your final answer, which is the square root or the cube root or the fourth root of a negative number is going to require an I. So we go to the next one right here. We know that this is going to end up being an I. I've got a 4 that's already on the outside. And I have 64, a negative, and then I've got a 64 right here. So that's 2 and 32. 2 and 16. 2 and 8. 2 and 4. 2 and 2. We need 4 of a kind to come on out. So it's 1, 2, 3, 4 right there. We've got 2 times 2 left over, which is 4. Do the same thing with our exponents here. We have 7 divided by 4. That's going to be 1 with a remainder of 3. So the 1's going to come out. The remainder of 3 is going to stay underneath. And then here I've got 23 over 4, which is going to be 5 with a remainder of 3. So the 5 is going to come out. The remainder of 3 is going to stay under. Now we're going to put everything together. 4 comes out. That just gets brought down. I've got a 2, 4 times 2. I've got an x. I've got y to the 5th power. Okay? And I also have this negative right here. That negative is going to be an I. So I'm going to go ahead and put it right here, because the I will go before the radical and after all the variables and numbers. Then I have the 4th root of 2 times 2, which is 4. X to the 3rd power. Y to the 3rd power. And then I'm going to go ahead and bring everything all together, which is just 4 times 2, change that to an 8. And put the absolute value around the x right here because it's to a 1st power. It's also, I've got a y to the 5th power as well. So these two need to be inside the absolute value. So you can write it like this. 8 times the absolute value of x, y to the 5th power times I, because of the negative right here, times the 4th root of 4, x to the 3rd, y to the 3rd power. And that takes care of your warm-up with simplifying radicals.